consider log a to base x equals to t. Okay, so by the definition of log, so this base will break this, so my a will be x exponent t. All right, now the base can never be 1. Okay, so x is not equal to 1. All right, so another one, log m to base 2 equals to x. So this base will raise this x, so I'll let m equals to 2 raised to x. All right, so now that we understand the definition of logarithm, let's use the definition of logarithm to solve the following examples. Okay, so I want to use the definition of log to solve this. Okay, all right, so let's set this one to a variable. Okay, any variable of our choice. So let's set this one to that, and we said the base will raise that, so I have 64 equals to 4 to the power x. All right, so we now go back to indices. So we need to change this one, that is 64. We know 4 to the power 3 the same as 64, because 4 times 4, 16 times 4, that is 64. All right, okay, so the bases are equal, so my x is straight away 3. All right, log 36 to base 6. Okay, so same thing, so let this one be y. Okay, so the base will raise this, so I'll get 36 equals to 6 exponent y. So 36 is the same as 6 times 6, that is 6 squared, equals to 6 raised to y. Therefore, my y is 2. Very, very simple. All right. Okay, so let's observe the following examples. All right, so we have log 0.25 to base 2. Okay, so let's change 0.25 to fraction. Okay, so the same as so 25 over 100. So let's change this one somewhere. 25 over 100. We say 25 here, 125 here, 4. So 0.25 is simply 1 over 4. So to base 2. All right. So let's set this one to any variable y. So my 2 will raise that. So I have 1 over 4 equals to 2 raised to y. So let's change the left hand side. Okay, now this one can be expressed in so many ways. All right, so I can say 1 over 2 to the power 2 equals 2 raised to y, whereby this one is same as 2 to the power minus 2 equals 2 to the power y. Therefore, my y is negative 2. Right. Okay, so let's look at the right hand side. So we have similar one here. Okay, so you can try this. So we have 1 over 27. So let's set this one to, let's say, p. Okay. So we have 3 raised to p equals to 1 over 27. So 3 raised to p is the same as 3 to the power. So 1 over 3 plus 3, 3, 9, 9, 3, 27. All right. Okay, so my 3 raised to p is the same as 3 raised to negative 3. Therefore, my p is what? Minus 3. All right. Okay, so you can try this. Log 1 over 16 to base 2. So you can try this one. All right. You can put the answer under the comment section below. All right. Okay. So let's look at the laws of logarithm. So let's look at the laws. Okay. So the first law has to do with this. So addition law, that is product rule. So log a to base x plus log b to base x. Okay. Now the law, this law only hold when the bases are equal. So make sure the bases are equal before you can apply this law. Okay. So we have plus. So this one is product rule. So it's the same as log AB. I'll multiply AB, then I'll pick one of the bases. So this one is simply the product rule. Okay. All right. So in case we are given log, so example, log 5 plus log 3. And one more thing, if you don't see the base, it's 10, okay? In case we're given a question like this and you can't see the base like this, okay? It's 10. Okay. So this one is a product. The bases are equal, so I'll just multiply. So this one will be log 5 times 3, which is 15. Log 15 to base 10. Okay. Now note that log 7 plus log 2 is not equal to log 9. Okay, don't think it's addition and therefore 7 plus 2 is 9. No, it's wrong to say that. All right. Okay, so the second law is called quotient rule. Okay, so let me repeat the same. Log a to base x. So this time it's minus. Okay, log b to base x. So the first law was addition here. So this time is subtraction. Okay. So this one is called quotient. So division. So this one is so a over b. Okay. To base x. All right. So call this one quotient rule. Okay. So example, log 25 minus log 5. Okay. So this one is simply log 25 over 5. Okay, so 5 and 25 is 5, so the final answer becomes log 5. And yes, of course, if you don't see the base, it's 10. All right. Okay, and note this one also, that log 7 minus log 5 is not the same as, so I say 7 minus 5, therefore 2 log 2. No, it's wrong. Okay, so this one is not equal to that, so take note. All right. Now let's look at the third law, that is called the power rule. Okay, log a to base n, sorry, log a exponent n to base t. Okay, so we call this power rule. So look at the power here. So the power come here. So this one will be n log a to base t. So we have this. So in case have something like log 5 exponent 2 base 10. So this one is the same as 2 log 5 to base 10. Okay, so that's that. Okay, let's look at the properties of logarithm. Okay, so the first one has to do with log a to base a. Okay, so logarithm of a number to the same base as the number is 1. Okay, so I made mention of if you don't see the base. Now, if you take log 10 on the scientific calculator or on your calculator, it will give you 1 because the base is 10. By default, the base is 10. And log 10 to base 10 per the property is 1. Okay, that's the first property. All right. So the second one has to do with log 1 to any base, log 1 to base x. So log 1 to any base is seen as 0. Okay, so example, log 5, sorry, log 1 to base 5 is 0. All right. Okay, so the third one has to do with log of a negative number to any base. So you cannot take log of any negative number. So this one does not exist. Okay, so you can't take log negative 5. Okay, or log of any negative number is wrong. Okay, to say that, so it doesn't exist. All right. All right, so now that we know the laws and the properties, let's simplify the following. Okay, so the first one has to do with 2 minus 2 log 5. Okay, so don't say 2 minus 2, so 2 cancel 2. No, it's wrong. Okay, well, we need to support this so that we can apply the laws. We know log 10 is 1, okay? And we can write this one as 2 times 1 minus 2 log 5. But 1 can be written as log 10. So 2 log 10 minus 2 log 5. Don't forget the third law, which says log a to base log a to the power t to base x is the same as, so this one is power root t log a to base x. Okay, so this one the 2 come here, power, so log 10 to the power 2 minus log 5 to the power 2. So this one becomes log 100. Okay, so this one 100 minus log 25. So minus quotient, so we need to divide. So log 100 over 25. So 25 into 100 is 4 times, so 1 4. So the answer is log 4. Okay, let's look at half log 9 minus 1. Okay, so this one is a power rule. Okay, so this one is the same as log 9, okay, to the power half minus, so 1 can be log 10. Yes, log 10 is the same as 1. And 9 exponent half is the same as square root of 9, or 3 to the power 2 times that. So this one is power, this one will cancel 3, and this one 3. Since we can't take log of a negative number, you can't say plus or minus 3, right? So we ignore the negative part of it. Okay, so this side becomes log, okay, 3 minus log 10. So the final answer becomes log 3 over 10. All right, so that's that. Okay, let's look at this example. So we have log 125 on log 5. Okay, so let's express this 125. You know, 5 to the power 3 is the same as 125. So we can say log 5 to the power 3 on log 5. Why are we expressing this one as this? Because we have the denominator here as log 5. We want to cancel out, because we can get this denominator in the numerator. Okay, so this one is the same as 3 log 5 on log 5, and therefore this one will cancel. And my final answer is 3 on 1 is the same as 3. Okay. Okay, let's look at this example. All right, so we have quotient, okay, then we have product. All right, so let's apply the laws. So we have quotient, that is division. So the bases are equal. So I can write 1, okay? So this side will be 98 over 30. So this one is plus, so put that times 15. Okay. So 15 here 1, 15 here 2. I have 2 into 98 is 49. So I have 49 to base 7. Okay. So with this, we can use two ways. We can use the definition of logarithm to solve this, or we can use this property. So in case you have log a to base a is 1. So we can express this one, that is 49 to base 7, as log 7 squared is 7, which is 2 log 7 to base 7. And this one will 10 to 1. So my final answer here is 2. So this one is equal to 2. Or you can set this one to any variable, which will be 49 equal to 7 raised to y. So 7 raised to 2 is same as 7 raised to y. Therefore, y equals 2. Whichever way, you get the same thing. All right.